In this video, we're going to look at some different ways to factor polynomials, and I'm actually going to have to make several videos of this, so this isn't too long. I'm sure you've all factored before, so this will be more of a review for most of you, but if you factored before, you know there's like 5 or 6 different ways to do it, so I don't want to cram all of them into this video, so we'll just look at a few ways, a few different methods of factoring for this video, and then I'll make another one with a few more. So to start off with, the first type of factoring is looking for a GCF. GCF stands for greatest common factor, and basically the idea is if I have something like 2x plus 2y, I look at both terms of that polynomial there and I say, what do they have in common? In this case, both of these have a 2 in common, so I factor that 2 out to the front, and then I just say what's left over. I had a 2x, I factored out a 2, 2x divided by 2 leaves me with an x. I had a 2y, I factored out a 2, divide the 2 out, you're left with a y. And there we go. That's pretty much the most basic, standard, simple way to do it. I can actually check this if I want by distributing. 2 times x is 2x, 2 times y is 2y, and I'm good to go. But then we can obviously expand on this a little bit. For the sake of argument, suppose we have 3x squared plus 6x plus 9. Now I have 3 terms, but if I go term by term, I have a 3 here, a 6 here, and a 9 here. They all have a common 3 in them. Factor that out. And if I factor it out, now I just go term by term. I had a 3x squared, I factored out a 3, I'm left with x squared. I had a 6x, I factored out a 3, I'm left with a 2x. Make sure you divide. To check it, 3 times 2x is 6x. I had a 9, I factored out a 3, 9 divided by 3 is 3. And then just to check myself, I could look at what's left over and say, are there any other common factors floating around? And clearly there aren't. There's an x in both of the first 2 terms, but there isn't an x in the third. The GCF has to be common to every single term in the polynomial, so I'm done. Just 1 or 2 more of these for a couple of points. Suppose I have x cubed plus 6x squared plus x. Looking at it really quickly, they clearly all have an x in them, so I factor the x out to the front. X cubed divided by x is x squared. 6x squared divided by x is 6x. Here, the tendency is to leave that blank and just say, oh, I had an x, I factored out an x, so I'm left with nothing else, 0. The problem is, if we just check it by foiling, x times x squared is x cubed, x times 6x is 6x squared, but this x just disappeared. And the trick here is when we factor, we're factoring multiplicatively, not additively, which essentially means when I do x divided by x, I don't get 0, I get 1. Now if I check it, x times x squared is x cubed, x times 6x is 6x squared, x times 1 is x, and I get what I want. So just make sure when you're doing this, if you factor out a GCF, if you factor out an entire term, don't leave it blank or write 0. You need to put a 1 in there because we're factoring multiplicatively here. The last thing we'll do with this, just to kind of make it as messed up as possible, suppose I have x squared y cubed plus 2xy squared plus 6x to the 4th y cubed. Now I have a whole bunch of variables raised to powers floating around, but I do the exact same thing. I go term by term. For the constants, that's a 1, that's a 2, that's a 6. They don't have anything in common, so leave the constants alone. For the x's, I have x squared, x, and x to the 4th. What is the highest number of x's they all have in common? In this case, 1, because this only has 1. So I'll factor that out. For the y's, y cubed, y squared, y cubed. The highest number of y's any of that they share is y squared. They all have at least 2 of them. So I factor out the y squared. And now I just go term by term. I had an x squared, I factored out an x, I have 1 x left over. I had a y cubed, I factored out a y squared, I have one y left over. I didn't touch the 2, so that stays. I had an x and I factored out the x, so that's gone. I had a y squared, I factored out a y squared, so that's gone. Here, I didn't touch the 6, so leave that alone. I had an x to the 4th, I factored out an x. There's 3 x's left over, so x cubed. I had a y cubed, I factored out a y squared. I had 3 y's, I factored out 2 of them, so I have 1 left over. And there we go. There's my polynomial in factored form. And again, if you just look at the inner terms, there's a 2, it's got nothing in common with either of those. The xy doesn't have anything in common with that. This thing doesn't have anything in common with both of them. So clearly, I factored out the GCF. There's nothing else that they all share. Okay, now we want to look at another type of common factoring. Trinomials with a leading coefficient of 1. Now essentially we want to look at things that look like, we'll say x squared plus x minus 6, or x squared plus 13x plus 30, or maybe x squared plus 5x minus 6. I will go with plus 4 actually, just for fun. We want to factor things that look like this. They're trinomials, they each have 3 terms, and the leading coefficient is 1. This is the most standard type of factoring of trinomials, and to kind of make this video a little bit brief, I won't spend a lot of time going into all the math of how to solve these. The basic trick is, we'll start with this one on the right. If I'm going to factor this, I know it will factor to 2 factors that look like this. And now I just need to figure out what goes in here. I know how foiling works, and I know that when I foil, whatever the 2 leading terms are, they have to multiply to that leading term. But the only 2 things that multiply to x squared are x and x. So that's good. Now for my second terms, right here, I know whatever they are when I FOIL, I have to end up with 30. The problem is, well, 30 times 1 is equal to 30, and 15 times 2 is 30, and 10 times 3, hopefully I get them all, 6 times 5, and that should be all of them. And in this case, well, now I have 4 different combinations of numbers that can go here. But the trick to this is, I can look at the middle term, the middle coefficient. And whatever 2 numbers multiply to 30, but also add to 13, those are the numbers I want. And we'll show why in a second. In this case, if I run down the list, 30 plus 1 is 31, that's out. 15 plus 2 is 17, that's out. 10 plus 3 is 13, that's good because I want 13. 6 plus 5 is 11, that's out. And there's only one set of numbers that actually give me a sum of 13, so I'm going to put those in there. X plus 10, x plus 3. And I would point out when you're doing this, as you practice these, and we'll do a few there is only one set of numbers that can make that work. These solutions are unique. And the reason it works, again, once we have those answers, if we FOIL, x times x is x squared, x times 3 is 3x, 10 times x is 10x, 10 times 3 is 30. And if I combine like terms, I get x squared plus 13x plus 30, which is exactly what I want. So now we kind of understand how the trick works. So now we'll just practice it a couple of more times. Here, well, my constant this time is a negative x, a negative 6. My leading term is still x squared, so I'll still get an x and an x. But now I need numbers that multiply to negative 6. I'm aware with practice you can do these in your head, but just for the purposes of this, I'll write them out. The only way I can multiply and get a negative number is if I multiply a positive times a negative. So let's see, I can multiply 6 times negative 1, negative 6 times positive 1. 3 times negative 2, negative 3 times positive 2. Those are all the things that give me negative 6. And if I run down the list, 6 minus 1 is 5. I need a 1 there, so that's out. Negative 6 plus 1 is negative 5. That's out. 3 minus 2 is positive 1, which should be good. I'll check the other one to be sure. Negative 3 plus 2 is negative 1. That's out. And again, I only get one solution. X plus 3, x minus 2. I'm not going to FOIL this one out, but you certainly could if you were unsure. And then now, just to practice one more time, I'm still going to have an x and an x. I need two numbers that multiply to 4 that add to 5. 4 and 1 or 2 and 2 are the only things that multiply to 4 that are positive. And if we check really quickly, 4 plus 1 is 5, so that's good. 2 plus 2 is 4, so that's out. And I only get one solution. X plus 4, x plus 1. And there we go. This is pretty straightforward and simple. And with a little bit of practice, as I'm sure you've all done before, you can work these pretty well. We will use this a lot in this class, and you use it in trig, you use it in Calc 1, Calc 2, so it is a really important skill. So if you're good with your factoring, good. If not, we'll do a lot of practice in this class. And like I said, I'm going to make another video with some more complex methods of factoring.